Okay, now the record is back on. You see how we can solve the axial forces here. So it's pretty similar here. Once you have for the joint on the second floor, once we have the shear from the columns. Okay, it's similar, and we can try to do the same. It's going to give you the same results. For example, if it joins here, now you know you have 40, you have 20 over 6 coming down here. Oh, sorry, that's from top, right? That's wrong. You have the 10 coming down here, and then 20 over 6. Now you will know how much this is, but it should send the force over. So let me try to find a number. That's this is 100 over 3, 100 over 3. And then you move on to the next. And this becomes the force 100 over 3. And then you know you have now 20 from the column underneath. You have 20 over 3 from the column both. And it's simple enough. Okay. And this here for the next joint, you notice that this column, I mean beam, is going to give you the moment here is going to be 110 over 3 as well. So the next joint is going to be pretty similar to this, because you have the joint from the top column and then the bottom column, which have the same moment, and then you got another 100 over 3 coming from here. So the next joint is pretty similar to this, and then the next member is going to be pretty similar to that. Okay, so no big deal. Is there any question you want me to clarify something before we move on to the cantilever method? Anyone? Hello?
Could you show for joint H just only one?
Joint what?
Joint H.
H?
Yeah. Because I try to do it and the moment is not to sum up to be 0. I don't know.
So let's say joint H, where are we? Here, right? E, F, G, and H. Well, let's see. We're gonna have each other because it's so many numbers. Joint H, it's that one, right? So we have to have the moment from this column. Okay, that one. It's 20 over 3 clockwise. And you have another one from this, which is 30 clockwise. Looks to be okay to me, because you know the moment at the beam is going to be 110 over 3. But this is 90 over 3 plus 20 over 3. So you have to have the moment here equal to 110 over 3. Right? And this, remember that this is your second beam in the floor. It's FG. So your GH. Okay, this is GH. If now I'm doing things backward here. If,
oh, I see.
This is 110 over 3, and another one, it should be like this, which coming from the joint, which is going to be similar to this. It should be okay, right?
Yeah, it's all right. Thank you.
It's just you're gonna, you know, if your level of concentration is not high enough, you're gonna miss something. And generally, I have to say that when I look at the graded exams, one thing is very clear, is that many students did not practice. They just, okay, I'm taking a look, I will take a look at my exam, I'll take a look at some examples and I'll be okay. But that's what happens. So when you look at this and say, okay, I'll be okay because I understand, but you don't feel the, the trend of the numbers. If you practice more, you will sense what kind of numbers you should expect. For example, you see, you're beginning to see that, okay, if it's a usual case, see the moment here, it's going to be equal in the beam members, and so. And the joint here is going to be similar to the next joint, something like that. But this kind of sense will come to you only when you see a lot. And you should know that I've given you a lot of exercises through the active session. But because of the COVID, because of the online format, generally not many can complete even one example or one exercise in the time frame. But that doesn't mean that you should not do anything beyond the class. And the thing is, more students don't. And, you know, they suffer. And if you ask me, they deserve it because they did not invest the time on it. So how would you expect to be able to do things when you don't invest? Okay. So anyway, this is as a guideline. Practice. The next is the Cantilever method. And I am now glad that we have done this because you know, if you can do this, you know, from here, if you use the portal method, 4 unknowns are solved by and it comes out in terms of shear. Okay, they're solved by portal method, and you have the shear. So that means if we are going to take the cantilever approach now, we have basically the same situation here. So we have 4 unknowns, but the 4 unknowns will be solved differently. So it's different in the beginning. Okay. So now let's again free body diagram. Okay, 20. And now we cut the free body diagram at the hinge, right? And we sort of know that this is your neutral axis because the columns are symmetric. And if I shift the column so that you don't have any symmetric structure, can you find the neutral axis? Can you locate the neutral axis of the columns? Some can, some have no idea. And you know, you have done mechanics of materials before. Funny. So now let's say we are going to take the moment here. Sigma moment equal to 0. Okay. And now you would know that this better be compression and this better be tension. Correct? So we take the moment here at again at the line of the hinges. So your moment from the external force is 20 multiplied by 2, correct? But now, before that, let's say this distance is 3 plus 8, so it's 11 meters. Correct? Because we have this is 8, this is 6, and that's 8. So that's 11 meters right there in the middle. I'm gonna take this out, okay? So now you, from this, you will know the proportion of your force by using a similar triangle or whatever you want to call it. So that is, this distance is 3. The whole distance is 11. So that means this P is, sorry, This P is 311P. If that is P. Are you with me? It has to be proportionate.
Yes, yes.
So if you say, okay, the biggest one is P, that has to be 311P. Okay? And that is 311P. That is P. Just basic similar triangle to find a ratio because we believe in elastic, right? So that means the moment internally, we have the two of 311Ps and we have 2Ps. So I multiply everything by 2. Everybody has P, so I'm bringing that out. So we have 311 of P multiplied by this moment arm, which is 3. And then we have P, which is 1, multiplied by the moment arm here, which is 11. Okay, simple enough. No, you don't even need to be taught to do this. Okay, so from here, we have P equal to 22 over 13 or 1.692 kilonewton. And now we move on to the next free body diagram. Now you have 20, you have 40. And remember, we cut the free body diagram right at the joint again. And again, the neutral axis is in the same place. And the ratio of the force is again the same. I don't know, I have to create a dotted line. That is 11. This is 3. Okay, so now taking the moment, it's going to become 20 multiplied by 7 now, because here is 3, right? And that's 4. Plus 40 multiplied by 3. And again, this is going to be equal to 2p. It's exactly the same as that, right? 2p 9 over 11 plus 11. This time your p turns out to be beautiful. It's 11. Okay, so we do this. We now have solved the 4 unknowns. Okay, but it's a different approach. Remember, in the portal method, you have the shear in the column. This time you have the axial force in the column to begin with. So we can go ahead and try to impose that on the structure. So we now can perhaps begin by taking a look at the B. Okay, but that is going to be where's the name? IJ. Okay. Now you have the downward force. So for IJ, it's going to be that. It's a hinge. And you have 22 over 3 coming in from the leftmost column. Okay. Now you should know that, okay, if you have a sigma Fy equal to 0, you have to have that. Okay, now you can calculate your moment, which is going to be equal to simply multiplying this by the moment arm 4 meters, because that is 4. So that becomes 88 over 3. And similarly, you have that 88 over 3. Okay. So now move on. You will face the joint. And you have this number 22 over 3 from this. And then you have this one is 3/11 of that. Okay, so it's 6 over 13. Correct. Now 6 over 13, 3/11 multiplied by 22 over 13, right? So that's 6 over 13. So that's how we got it. So that's 6 over 13. So coming in from here, now you can determine this. That's going to be 28 over 13. Now you can move to your second beam here. That is 28 over 13. And I forgot to draw the hinge. You gotta go back to pink again. Okay, now you can calculate your moment. It's going to be that one. And the moment is going to be equal to just 28 over 13 multiplied by 3, which is half length of that member, right? Then that is, you should be kind to write this down. It's over 13, right? Everything is over 13, right? So it becomes 3, it's like that. Okay, that's better. So Akrapan, you lost 2 now. Can help me keep track of everything?
Yeah.
Yeah, you lost 2, right? So this is 84 over 13. Okay. Meaning this is also 84 over 13. And from this, we now know that, okay, that's 28 over 13. Okay. And similarly, now we can move on to the next joint. This guy is 28 over 13 up, so that is 28 over 13 down. This guy is going to be upward, not downward, because it's a cantilever. So the direction of the force here is now up. See, be careful. So similarly, this one up, this one down. So this results in upward of 22 over 13, right? And you can now move to the last beam. That and that is going to be another 22 over 13 down. So that is going to be up. And you see, it's going to be back to this pattern. Similar shear, so similar moment. Just watch the direction. Down and up and down. Okay? 88 over 13. It is. So now you got the moment from the from the beam, you can transfer these moments to the columns. It's a bit of a you know, different direction from what we've done before. So I can now draw the joint and try to take the moments to the column. Let's move it down. Okay, now we have this, be careful, that's 88/3. That's what we got from the beam. We got that 88/3, so we got that 88/3 from this beam. Right? And then this guy is this, so that is 83/13. Again, it becomes 3, it's 13. This is this. Okay, and this guy is going to come here. That's 84/13. This guy is going to clockwise, so we have to have counterclockwise. 88/13. This guy is clockwise, so this better be counterclockwise. 88/13. Okay, so you know, now we can have the moment on the columns, right? It's 88/13. This guy is how much? 88 plus 84. That's 172/13. 172/13. And 88/13. Okay, so it's a similar process, really. Now we can move on to the columns. If you are okay with this, I think we can stop. It seems to me like you may get bored. But, let me continue on anyway. So here we have the this. Okay, and now the moment here, 88/13. 172/13, not point, the over 13, 172/13 and 88/13. So now you know where this leads, right? So it's going to be this, similar, of course, and you know the shear is going to be in the opposite direction now. Okay, and that shear is going to be 88/13 divided by 2. Okay, that is 172/13 divided by 2, because 2 is the distance. And let me remind you that. Okay, and similarly, so now we have the shear on the columns. You can take this back to this right away and then complete the free body diagram of the beams, right? And you can also proceed to the next joint. Okay, we have this, and then that. You know what's going to happen next? Can you guess? we have the forces now coming in from this. We have the forces from both columns. So we now can have the shear on the beams on the second floor and carry on. Correct? Because from this, you know, we have this. And we have 11. Right? This is from here. See, P is 22 over 13, and then this is 11. So there we have it. And the second one, it's 6 over 13, and that's 3. Okay. The next one is going to be opposite direction. So it's 3 and 6 over 13, and then this is 11 and 20. Keep missing this one. 22 over 13. Okay. So now from here, you can calculate the shear. Okay. I'm running out of colors. So you're gonna have shear here. Okay. And that is 121 over 30. Really? That's wrong, I think, because I didn't finish this, so I didn't check it to the end. So that's completely wrong, because 11 plus 12, so that's 140. It's 143 plus 22 over 13, right? Yeah, so it has to be 165 over 13. And when you have that, it means that you can now calculate this moment in this beam, right? To sort of take it back to the columns. That has to be 165 over 13. And then you can have moment. That is 165 over 13. That look like 3. Let me do it again. Multiply by 4. Okay. And then you can keep doing this. And likewise, you know that this is going to be similar. Because if this is 165 over 13, this has to be 165 over 13 up. So that is 165 over 13 down. You can carry on to this. So hang on. It's all downward. So this is going to be a huge force. Okay. And that's going to be, let's use screen. That's going to be how much? 165 plus 6 plus 39 over 13. Okay. And that will be our second beam. Okay, and we have the, how much is that?
210.
Pardon me?
210 divided by 13.
Like that. Thank you. So better be down here. Now you know this is going to be up. So now it's going to be down. The force is going to be down here. 210. So and things are going backwards now, right? Okay. So this minus this, and it's going to change the number back to 165, and then this is going to be okay. Yeah, you can see that, right? This is the moment, and then now you can calculate this moment. This is going to be 210 over 13. I have a problem writing number 3. This multiplied by, that's the beam, is 6 meters, so this is multiplied by 3. Okay. How much is this? 680 over 13, that right? Yeah, I think so. This is 630 over 13. And we keep doing it. Okay.
160.
Pardon me?
165 times 4 is 660.
Oh, 6. Yeah, right. 60. Yeah, sorry. Yeah, you're right. Thank you. Okay. So yeah, on and on, because now it's in the opposite direction. So you get 210. You got plus this and this and this, right? So that means by a quick look, this better be upward and 165 over 13, and so and so. Okay, and the number is going to be, you know, like a mirror image. Okay. And you have the moment here on the second beam. Then we are almost done. You can have the moment from the that. How much is that? You have 88, 13, and then you have this 660 over 13. So now you can have this. Okay, and then you take it to the column, and so and so. Okay, so you know, we have 10 minutes left, but I think this is already too much. And now you know the idea, because I think after, if you use the Porto method, you just use the assumption that the shear is going to be distributed as if the, you know, your frames are made of the portals tied together. And if it's a cantilever method, you know, you're just going to have to use the assumption that your frame will behave like a cantilever beam, and then you have the proportion of the forces like this, you know, to solve the unknowns. And once you have done these two assumptions, you know, either for the portal or for the cantilever, the rest is just completing the free body diagram. I don't even have to show this to you, you know, but that's all I have. The rest, it just goes on and on. If you have this, and then you have the moment from here, you're going to have the another beam here, and then you have the moment, and then, you know, you can bring the moment to from this to this, from sorry, it's supposed to be on this side, and this from this side, and then you have the from column above here, and then you have the moment on the column below, and then so and so. Okay, so I suppose that's it for today. Okay, because I didn't complete this example myself, but you should be fine. Okay, so any question? If you want me to continue to do this, you're gonna have to help me.
Can you go both?
Yes, until limit.
Can you open the previous page, please?
This page. This is where you want?
Yes, thank you.
Okay. So while I'm waiting for you, let me pause the record.